Hello and welcome. Thank you all for joining us. We are going to get started in just another minute or so, give some other people some time to join, and then we'll get started with this webcast. Thank you. Thank you to all who joined. We'll get started in just a minute or so. So hello, thank you for joining. I'm Sean Metcalf with Trimarc. Just a little bit about us. Trimarc does comprehensive security assessments. We focus on Active Directory, Microsoft Office 365, and Azure Active Directory, as well as VMware. We have security assessment engagements for each of these areas. These assessments are deep, in-depth reviews that are detailed and provide actionable recommendations. We want to make sure that you have the information you need in order to better secure your environment and get it to a better place. So we focus a lot on the reporting end of it, effectively doing an in-depth comprehensive recon of your environment, and then shift over to writing the best recommendations to help shore up your defenses, remove those potential issues and misconfigurations, because ultimately we want to provide a roadmap to improve your security posture. And a quick note, we're going to be doing our next webcast on Wednesday, June 17th from 1 p.m. to 2 p.m. Eastern. That'll be with me, Sean Metcalf. This is on part of our Securing Active Directory series. This is performing your own Active Directory security review. So you can register for this at trimarc.co/security-webcast. We will be covering the items and areas that we find that are the most common security issues when we perform Active Directory security assessments with customers, how to identify some of these more common items yourself, as well as the PowerShell commands that can help you identify what these are, and some typical results and some ways to clean that up and fix those items. We'll also provide a sample PowerShell script that you can use to run in your environment to see what sort of AD security concerns that may be identified by this as well. All right, so let's get started. A couple of webcast notes first. There will be a Q&A after the presentation, so please submit your questions and the moderators will review and publish them. Thumbs up, like the questions you want to hear answered. The most popular ones I will answer first. The links to the slides and the recording will be posted to the Trimarc webcast page at trimarc.co/security-webcast in the next day or so. The webcast is scheduled for an hour and the presentation is about 45 to 50 minutes. After the presentation, we'll do a question and answer, which may run past the 1 hour time scheduled. If the last one is any result, it probably will. I will stay online to answer as many questions as possible, but I have a lot of content, so let's get started. I am Sean Metcalf, the founder of Trimarc, a professional services company that focuses on helping organizations better secure their Microsoft platform, primarily. So this is Active Directory and the Microsoft Cloud, such as Office 365 and Azure Active Directory. We also have a VMware security assessment, which we just started providing for customers. I'm a Microsoft certified master in Active Directory and a Microsoft MVP. Fingers crossed that continues. And I've spoken at a number of conferences. I also run adsecurity.org. Okay. All right, that was fun. So that was the lightning round. Now we'll go at normal speed. I'm going to talk about attacking Office 365 and Azure Active Directory. Basically, what are the ways that attackers are going after this platform? The most common ways, the ways that they actually get access. Then I'm going to talk, as part of that, at the end of that attacking Office 365 section, I'm going to talk about a new attack path that I identified last year. I call this from Azure AD to Azure an unanticipated attack path. I'm going to cover this in the presentation. The slides will be available later, as I mentioned. There's also a blog post that's dropping on adsecurity.org later today, as well, following on trimarcsecurity.com, that covers everything that I talk about and the things that you can do to mitigate this potential attack path. And then after that, I'm going to talk about how to best secure Office 365, and then kind of wrap it all up, and then we'll do some question and answer. Password spraying. I'm sure a lot of people are familiar with this, but while it works on-prem against Active Directory, it also works against Office 365. There's a few different reasons for this, which I'll get into. Active Directory Recon, we're familiar with how an attacker can gain information about the on-premises Active Directory. They can enumerate a lot of different informations with simply a network access to a domain controller. Typically, they need authentication with a user account, but sometimes the domain controller is configured to not require that. But ultimately, you need to be on the network where the DC is with network access. While a domain controller may be available from the internet, that's not ideal or even close to best practice. With Azure Active Directory, this enumeration could be performed with an account once the person has access to all the Office 365 services, which is the internet by default. And what's really interesting about this is user enumeration is often possible without using an account at all. This is possible with a tool called O365 Creeper, which leverages a feature or functionality of the Office 365 authentication page, where when you type in your email address, it's then going to identify if that email address exists in an Active Directory tenant. Once it does, then it's going to prompt for the password and continue on with the typical authentication process. O365 Creeper, you give it a list of email addresses, and it runs through using this Python script to identify connecting to the Office 365 authentication page, looking for that result code. If it exists, then it's going to identify that. If it doesn't, it'll identify that as well. MS Mail Probe, which works against OA, which once you have an account, a valid account credential, and you're able to authenticate to Azure Active Directory, you can use this in order to gather information about the environment. I did look recently at some of these and found that Office 365 user enum now does not work. Microsoft closed whatever loophole was open that enabled that to work. But there's also O365 Recon, which leverages the MS Online and Azure AD PowerShell modules, kind of a quick and easy way to run a few of these commands baked into this PowerShell module, which will leverage the MS Online and Azure AD commandlets. Another thing to note is that with O365 Creeper, that's a great way that an attacker can get a credential to use or start in order to get a credential to use, because once they can identify what accounts are active in that Azure AD tenant, then they can perform password spraying. So I'm sure a lot of people are familiar with it, so I'll just cover this very quickly. Password spraying, put simply, is starting with a list of passwords and attempting to authenticate as each user in the user list or the directory with that password. If they can authenticate with that password, then they have the password associated with that user. If they don't, they just continue. It just continues on through the list anyway. After attempting the first password, the tool typically is going to sleep for a certain amount of time to avoid lockout. Then it'll attempt the second one. This is extremely effective because people are generally bad at creating passwords that we require them to using complexity. So they end up with winter 2019. Maybe there's an exclamation point, or spring 2020. Maybe there's an exclamation point. So there are a number of tools that can be used to password spray in Office 365 environment. From Ruler to Spraying Toolkit to Link Sniper to Mail Sniper. And why does this work? Password spraying works because of legacy authentication. Legacy authentication is this older method of authentication that requires a username and a password, and that's it. So the newer libraries and what's called modern authentication provides capability for a user credential or a user name, a password, and something like two-factor MFA, or even just passwordless, which leverages the FIDO2 spec. And when you think about legacy, think about the older protocols like POP, IMAP, SMTP, and basically Outlook 2010 and earlier. So we're going to use Mail Sniper in order to password spray against an Office 365 environment. We identify that there are some credentials here. And as it turns out, at least one of these is a global administrator, which is extremely bad because a global admin is the full administrator for the Office 365 and Azure AD environment. But that's not all about that, and I'll cover that in a little bit. So it used to be that you needed an Azure AD P1 or P2 license to even look at the Azure AD sign-in logs. Now, at least as of a number of weeks ago, Microsoft has opened this up so that you can go on the console, look at the Azure AD sign-in logs without needing any additional license. An additional license is still required if you need API access to it. So that means that if you're pulling some data or doing some sort of correlation which requires that API, then you will need to get Azure AD P1 or P2 in order to do that. But password spraying typically looks like this: a number of failures in a row, and then after a few failures or a certain number of failures, there's a success. And we can set up detection for this looking for sign-in error code 50126. This is invalid username or password or invalid on-premise username and password. And it shows the client app is other clients, older Office clients, which identifies this as legacy authentication. You can also use this similar method by looking at the client app, other clients, older Office clients, to see if legacy authentication is in use in your environment, because you definitely want to turn it off. If you enable security defaults, it will disable legacy automatically. And we'll talk about that a little bit later. There's also breach replay. Breach replay is also referred to as password reuse or replay, and it often starts with a tweet that looks like this: our team is currently looking into reports of stolen passwords. Stay tuned for more. And then inevitably a password dump gets out there with SHA-1 password hashes, and then the attacker can troll through this looking for a user email address that's associated with a company or a organization that they're interested in going after. And then often users are going to use the same password in that third party or website as they use in their corporate environment, which means the attacker could have that password already or attempt to use it against their corporate environment. A couple of ways to identify if this has happened. HaveIBeenPwned.com, you can set up domain notification. So you have to prove that you own a domain by setting up a DNS entry. But once you've gone through that validation, you can receive emails. Preferably set this up for say a group email address within your company, so that way you get notified. And then any public password dump is Troy Hunt's going to incorporate into HaveIBeenPwned. There's also a password hash sync, which enables you to sync up a hash of the on-prem AD hash up into Azure Active Directory, which is great for another number of reasons. But probably one of the most useful is that since Microsoft has this very large identity management system called Azure Active Directory, they see a lot of bad passwords. They see and can identify accounts that have been compromised because of bad passwords. They're able to flag those and identify those. But in addition to that, Microsoft also gets all the public password dumps. In addition to that, they're getting password data from private researchers, law enforcement, and a number of other sources. So they're going to have a much larger grouping of bad passwords, so to speak, or known passwords than even HaveIBeenPwned. But you have to leverage this password hash sync, which my understanding is it's enabled in over 95% of Microsoft's tenants anyway. Consent abuse. This is an interesting attack which involves OAuth consent. So users are fooled into granting permissions to an app that looks very familiar. It makes them feel like they need to use this, or they should be using this, or it's required by their company. There's two primary toolkits that I've been able to find for this: FireEye's PwnAuth and MDSec's Office 365 toolkit. And I'll show the graphic from MDSec because they were nice enough to provide a graphic on their website that covers this. And so you can see that the users connect to an HTTPS redirector that connects to an external server that's hosting the toolkit. But ultimately, the user is going to see this message. It's going to say that this legit app has these permissions that are required. The app would like to read your contacts, read your mail, read all your OneNote notebooks, read and write to your mailbox settings, full access to all files, basically everything. And once you click accept, that's pretty much forever persistent access to your account profile in Office 365. But this is not just an Office 365 issue. This is a larger issue because of how OAuth works. So for example, Trend Micro published information about PawnStorm that was sending phishing emails, targeted phishing emails to a certain organization. And it said, you really want to install the new Google official application, Google Defender. And Google Defender will protect all your things. So you definitely want to have Google Defender configured in your environment. And in order to do that, click on this Install Google Defender link, and then you allow it to view and manage your mail and view and manage the files in your Google Drive. Again, persistence, effectively forever persistence on this account and the data associated with it. The other thing that's interesting about this is, in the past, I've talked about Active Directory sneaky persistence threats or persistence methods. This is very much a sneaky persistence method for Azure Active Directory, which are the enterprise apps, these tenant apps that are tenant-wide, apply to all users. This is not the real Salesforce app. I created this and made it look like it is and said it basically wanted all the rights. So as an attacker, if I were able to get global admin rights for just a few minutes, I could do something like this, create it, and have some persistence within the environment. There's a few other things you can do around apps and service principals in Azure AD, which I don't have time to cover here, but maybe I will in a later presentation. The key thing here is that the enterprise apps are not often reviewed or looked at because a global admin can consent to it. Once a global admin is consented, it's kind of out of view. But it's also important to recognize that any permissions that are consented to for apps in your Azure Active Directory tenant and Office 365 at large, and I know that it's now Microsoft 365, are very much like what you'd have on your phone. Once you accept those permissions, you usually don't go back and check them. So it's a good thing to make sure that your app permissions are reviewed, and I'll talk about this a little bit more in a bit. The other thing that's interesting is that when you have a cloud service provider, cloud app, oftentimes you're going to sync some information from your on-prem AD up to that cloud provider. And this sync usually requires some sort of sync engine. It just requires user rights, so it can be configured by just about anyone that can have a user account or create a user account in Active Directory. And if you're using Office 365, you definitely have Azure AD Connect. So I was curious about what there was out there beyond Azure AD Connect, so I went ahead and used the trusty Googles to figure out what was there, and I got 32 million results. So I didn't have time to go through all 32 million results, but I did go through some of the ones that looked a little more interesting and probably more well-known. So just about every one of the major cloud apps or cloud providers you could think of has some sort of Active Directory sync tool. They have various levels of control as far as what they sync. Some just do a dump of specific attributes. Some may actually pull a lot more data about your users than what you might expect. I noted that one is just a PowerShell script that gets run on a scheduled basis. So at least you can look at that and tweak that if you need to. At DEF CON in 2017, I talked about Azure AD Connect as a potential attack path for an attacker that was interested in the on-prem environment because of cloud integration. So Azure AD Connect, when you install it using the express settings, these are permissions that the Azure AD Connect service account is provided. Replicate directory changes all. These are effectively what's required in order to use Mimikatz DC Sync. DC Sync provides the ability to pull the password hashes. It's using effectively what Azure AD Connect does in order to do password hash sync. With Azure Active Directory Connect installed on a server, it's going to reach out to the domain controllers and request passwords for those users who are having their password hashes synced. I mean, technically, it's a hash of a hash. And it's going to reach out about every 2 minutes, pull that hash, do some additional strong cryptographic hashing on them, and then send them up to Azure Active Directory. But what's interesting about this is if you've used the express settings, that MSOL account that gets created has a lot of information in the description, like the tenant that it's synchronizing with, what computer it's installed on, some other things. I found it interesting that it says what computer it's on, which means that as an attacker, we could try to identify what computer it's on and go after that system to attempt to compromise that system, to thus compromise the service account and potentially compromise Active Directory. Now, even if the express script isn't run, we can still identify what that account is, either by name or by the rights. Again, these two rights that are shown here in this PowerView script output. So we look again, we say Azure Sync. We're going to look for Azure Sync in the Active Directory environment. We identify it's in the root servers OU underneath the Active Directory domain for Acme. And we're going to use PowerView's find GPO computer admin commandlet. This is going to help us identify what are the Active Directory groups that have local admin rights on these systems for any system that's in this OU. So we know that this server, Azure Sync, is in the server's OU, so we target that. We identify there's a server admins group. This means that if we can compromise an account that's in the server admins group, then we are able to compromise that server since we'll have full admin rights and thus compromise Azure AD Connect to then further pull password hashes for privileged accounts in the environment and then use those hashes in order to compromise AD and do what we want to. Additionally, we can look to see what other group policies are applied. We see that in addition to the server baseline policy that's adding the server admins as a local admin, there's also 3 server tiered groups that all of them have modify rights to this GPO, which means that through this GPO, we can install code, run code, change security settings, add local administrators, basically anything that we want to. So these are a few different ways that we could potentially attack an Azure AD Connect environment. So the real important takeaway here is that you want to protect your Azure AD Connect server and protect it like it's a domain controller, even if it's not currently doing password hash sync, because there's a few other components that are controlled or optioned through that, such as Azure AD Seamless Single Sign-On, which has some potential issues as well, which I may cover in a later webcast. So let's talk about my unanticipated attack path. So for most of 2019, I was digging into Office 365 and Azure Active Directory and looking at the features. As I went through each of them, I found out that one was pretty interesting. And while Azure leverages the Azure Active Directory for some things, the Azure AD roles don't typically directly affect Azure, at least Azure RBAC, those role-based access control role groups that are there. So I'm going to detail and dig into a known configuration, at least to those who have dug into Azure AD configuration options, where it's possible for a global administrator, aka company administrator in Azure Active Directory, to gain control of Azure through a tenant option. Now, this is by design as a break glass or emergency option that can be used to gain or regain Azure admin rights if such access is lost. But I want to explore the danger associated with this option and how it's currently configured as of now, May 2020. The key takeaway here is that if you don't carefully protect and control your global administrator role membership and the associated accounts, you could lose the positive control of the systems that are hosted in all of your Azure subscriptions as well as Office 365 service data. So let's take a look at Office 365 administration. So we start with the global administrator, company administrator. This provides full admin rights to Azure AD and ultimately all your Office 365 services. The Microsoft Online document provides this key information that I'm showing here, this is current as of May 26th. But note that there's nothing here stated about Azure capability. It says Azure Active Directory, it's Exchange, SharePoint, again, the Office 365 suite. And once we have access to the Azure AD portal, which typically all Azure AD users have by default, we can view several different configuration options for Azure Active Directory, which again controls many aspects of Office 365. This is the directory properties page, which now includes the managed security defaults option at the bottom, which should be turned on. We'll talk about that in a bit. But just above that and at the bottom is access management for Azure resources. And there's a toggle between no and yes there. So let's see what that is and what that means. So according to the Microsoft documentation, toggling this option from no to yes adds the account to the user access administrator role in Azure RBAC at the root scope, which typically has control over all subscriptions in the tenant. This option is only available to accounts that are members of global admins. You have to be a global admin in order to actually toggle this from no to yes. While this option is configured in the directory property section, this is actually a per account configuration option. So this magic button provides the ability to manage Azure roles, but no direct Azure rights, such as to VMs. So further in the documentation, there's additional context on what Elevate Access is and how it works. So when developing Azure AD and Azure, Microsoft had to decide if the global admin should have Azure rights initially, and opted for no, they shouldn't, but provided the capability to gain this Azure access. This is what is sort of like a backdoor, kind of. And this has somewhat been highlighted. I think more people are finding this now that the managed security defaults option is just right below it, and Microsoft's pointing them to that. This graphic shows what happens and the connection point between Azure AD and Azure itself. At the top is the Azure Active Directory tenant, and then it shows the Azure roles. And while Azure AD is leveraged for a number of Azure components, Azure IaaS components, the Azure RBAC does not show up in your Azure AD portal itself. So there is some sort of like weird separation, even though they're kind of loosely connected. But my biggest concern here is that for many organizations, the group that manages Azure Active Directory and Office 365 are often a different group than those that manage Azure. This means that someone could elevate access, think rogue admin, and it's likely no one would notice, which is potentially a serious threat from an insider threat perspective, especially given the story around detection of this issue, which I'll cover in a bit, but you're not going to like it. I also found that there's an API that seems related, which means that an attacker doesn't even need to visit the Azure AD portal to perform this action. Just get global admin rights for a short amount of time, leverage the API to elevate, and then jump over to Azure. This note in the Microsoft document highlights an interesting phenomenon with this option. Only while the account is a member of the global administrator role can the account toggle this option to yes or no. This means that if the account no longer has global admin rights and this account is, or this option is set to yes, it can't be changed back to no. So the key to point or thing around this option is you have to be a global admin to turn it to yes, and you still have to be a global admin to turn it back to no, to disable it. So this note here just identifies that that is the case, and I've tested that out. So in the event that a global admin account is compromised, let's say that Acme is just starting out with Office 365, they're doing a pilot. They've been using Azure for years as their cloud data center. They have on-prem Active Directory domain controllers in there. They have SQL servers. They have a bunch of different applications that they've been leveraging, all stored within Azure, all protected within Azure. Now they've stood up their Office 365. They're doing a pilot. They've gone ahead and added their Active Directory admins as global admins or Exchange admins because they're doing that pilot. They've added some SharePoint admins. So there's a bunch of global admins in there. But none of them actually have MFA enabled because given the numbers around MFA from last year and even into Ignite, they're still not great. I believe they're probably still hovering around 10%, unfortunately. So again, by default, this option is set to no. And once toggled to yes, the account is added to the User Access Administrator group at the root of Azure. So it applies to all subscriptions. So in this case, we're going to toggle that option to yes, and then we're going to see a new account that appears in the User Access Administrator Azure RBAC role. So we shifted over to Azure. We're looking at Azure now on the subscription, and we can see that this one subscription has this new account, which I called Hacker, so I don't forget which one I'm using for this. But you'll also notice that I added a couple of others that look like they belong, an Azure admin, an Azure AD service account. These are not real. I just created them and threw them in there and used them through this weird toggling system. So monitoring for this can be a challenge since the primary method is running an Azure CLI command at the root scope. I can't find root level Azure RBAC roles listed in the portal, so this seems to be the only real good way to do it unless you're calling an API or doing it programmatically. And this is what you get when you run that, so you're going to have to do some parsing of this format. And as far as removing it, if you try to go into your subscription and you see that there's something in User Access Administrator for your subscription, and it has the root level, a level that's set on that, you'll get this message and says that anything created at root scope has to be removed by using command line, and this is the command you have to run. So when an account also, weird thing about this is when account toggles elevate access from yes to no, it does remove it from the User Access Administrator at the root level, which is good and should be, you expect that. So once the attacker has User Access Administrator rights at the root level, this account can modify roles for any subscription in Azure. We could go ahead and throw it into owner, which would be obvious and probably monitor, maybe. But what about something a bit more innocuous or a little more stealthy? So I decided I would go ahead and dig into the Azure RBAC roles to figure out what's possible. And one of the ones I found was very interesting was virtual machine contributor. And in the documentation, it says, lets you manage virtual machines, but not access them and not the virtual network or storage account they're connected to. I'm like, great, this would be something that a lot of people would set up and provide server admins and application admins or whatever to, so that way they'd be able to tweak the VM, but not really do anything with it because it sounds like it doesn't have anything that's all that privileged. Except I saw this one right that says Microsoft.compute virtual machines run command. I was like, what is that? That sounds really cool and interesting. And basically that controls this screen, run command. So run PowerShell script was the first one up there. I like PowerShell. So I figured, well, how does this work? Well, this run command option provides the ability to run commands on the VM as system using PowerShell. And a little further down, you see enable admin account. This includes the ability to re-enable the administrator account if it's been disabled, which on a domain controller in Azure, this would be the RID 500 account for the domain. When we're doing Active Directory security assessments, we find that a number of organizations have actually disabled this RID 500 account. Even if it has a spin or an old password, it's basically disabled and ignored. So in a scenario where, again, Acme is just moving in Office 365, they've added, let's say, 50 global admins because they're not doing anything with Office 365 yet. There's no real data there, so they're not too concerned about it. But Azure has all their important servers, including the majority of their domain controllers that they use for their on-prem AD. And they've disabled this administrator account, this RID 500. If an attacker could get access to this, they could actually enable that admin account after identifying that it has a spin and using an attack called curb roasting. They could take that service ticket for that administrator account for the domain offline, curb roast it, identify what that password is, and then run this, which would enable that admin account again, and be able to leverage that to compromise the environment. And all they have to do is disable that admin account. And how would someone know what happened in that environment? That would be very interesting. So we go ahead and add our attacker account here. I'm calling it hacker again, because if I don't, I'll forget about it. But I threw an Azure AD service account because why not? And it's probably not monitored. Membership virtual machine contributor, again, sounds very limited, so it's probably not very well monitored. So what we're going to do in this first scenario is we identify that Acme has a domain controller that is in the Azure subscription, which we now have control of through this Elevate Access method. And we're going to run net local group administrators and add an account that we were able to compromise while on-prem. Or we could just add a bunch of accounts that we are going after or targeting on-prem. But in this scenario, we would need some sort of access on-prem in order to have control of that account, or maybe not, because we're on the domain controller. So technically, we could even create an account and add it to the administrators group, and then we would have full control once we jumped onto the on-prem environment. So now that our attacker can run these commands, this command running this will update the administrators group. And since this happens on an Azure-based domain controller for the on-prem AD, it's going to replicate to any DCs that are on-prem and be used for any of the clients for this Active Directory domain or environment. So keep in mind that being able to run commands on an Azure VM is not specific to domain controllers, even though that's what I'm highlighting here. These domain controllers hosted in Azure, but also any other system hosted there as well. So we can run a number of commands, again, as system, and compromise SQL, compromise other applications, or really anything we want, and pull that data out. So we switch over to the on-prem environment. We go ahead and run our command to see who the member administrators are, and then there's that account, which has been added because of this Azure run command on that Azure VM. So we've compromised the on-prem AD from Azure because we had global admin rights. And if PowerShell logging is configured appropriately and sent to a SIM and monitored, which we talk about in every Active Directory security assessment we do recommend PowerShell be monitored, especially on sensitive systems, and flow that into a SIM. This event should identify unusual activity. This looks very weird. It says invoke command, and it's net local group administrators, and we can identify what system it's being run on. This seems really weird. And if you look down, you can see the user is acme /system. It's very odd that system would be running a PowerShell command that would do something like this. But that's not all that's possible with this, because this is just going to give us an account that has admin rights and could be fairly loud, or could have something else. But let's make this a little bit more interesting. So an attacker could leverage invoke Mimikatz and run this through this PowerShell command script, either from the internet. Here I'm using the standard but obvious new object net.webclient.download string, and I'm pointing to GitHub user content directly from the internet. Or I could also point to a compromised system on the corporate network, or even within the Azure tenant. And what I'm doing here is I'm pulling the password hash for the kurbtdt account for the Active Directory domain associated with this domain controller. Once I have this kurbtdt password hash, I own Active Directory, because I can create golden tickets with that for typically years, and probably no one's going to notice. I mean, it's possible if there's security tooling on the system, they're going to see Mimikatz. But if I adjust it enough, change things enough, I could effectively backdoor this domain controller in a way that would not be obvious. So let's recap a little bit of where this came from and how this came together. So Acme has a pilot in Office 365. They added 50 global admins because that's how pilots work. They added Active Directory admins, Exchange admins, SharePoint admins, basically anyone that's managing anything in Office 365, they went ahead and added. No one set up for MFA. They weren't worried about Office 365 because they didn't have any data there. Everything they had was in Azure, but everything they read said global admins control Office 365. So an attacker compromises a global admin in Acme. They had a really bad password that they configured. It was password sprayed and compromised. So either way, whether they are just starting with Office 365 or didn't realize the risk around protecting these global admins, either way, the global admin accounts weren't locked down with PIM or conditional access or MFA. Or there's another possibility here. When a global admin authenticates to Azure Active Directory, they get a session token that's stored in their browser session or whatever that app is, but usually it's a browser session when you're going to the Azure portal. This session token, if stolen, could be leveraged by an attacker if the attacker compromised their web browser. So if you think of a scenario where many global admins are actually using their web browser on the regular user workstation, and the browser gets compromised or the workstation itself gets compromised, if the attacker can extract that session token, which is not difficult, it's effectively a cookie, and reuse that, they have about an hour to perform any action they want as a global admin. So they can compromise the account. Once they've done that, they can elevate access to Azure through the API or the portal. They can get the Azure rights that they want through Azure role membership, because they can add themselves to whatever they want at the root level, any subscriptions associated with that tenant. They can remove the elevate access rights, so that way it looks normal. Perform any malicious actions on any or all of the Azure VMs in any or all of the subscriptions, then remove the role membership in Azure or not. And the total time required to do this would only be a few minutes, perhaps as much as, 15 minutes total. So this is why I highlight this as a potential attack path and one that's concerning to me, because as you walk through the process, the attacker from global admin to user access administrator has the ability to control so much within Azure. And this connectivity is not obvious at first glance. So the key takeaways here are, as I've described in Microsoft, customers don't usually expect that global administrator role that says it has Office 365 admin rights can also control Azure subscriptions. You got to be very careful what accounts are members of roles in Azure, especially at the root level, because it applies to all the subscriptions, but also at the subscription level, because it impacts your security posture. And it's not obvious that removing the account from global administrator role doesn't remove the account from the Azure RBAC role user access administrator. So even in the scenario where these 50 accounts are in global admins and someone decides to clean them up, but the attacker had flipped that bit stays set to yes. It can never be removed unless that specific person goes in and toggles it back to no when they have global admin rights. It is not possible to flip this from yes to no when you're not a global admin anymore. So the key points around this is problematic for detection. There's no good way to detect this configuration in Azure AD. There's no property to query on the accounts. You have to run an Azure CLI command to check the role group membership in Azure. And that's on the Azure side, not on Azure Active Directory. And when I walk through this Azure AD to Azure Access Elevation, I attempted to identify a clear event that I could alert on, and I couldn't find it. It just wasn't there. I saw that there was a core directory management set company information log, which notes that something changed, but not what. There was no detail at all. And then it just said no modified properties. So maybe you trigger off of that and think that it's that. I'm not sure. So I have reported this to Microsoft, and they said the capability for an Azure Active Directory global admin is by design. However, I see this as not expected and not well documented by Microsoft when reading about what an Azure Active Directory and Office 365 global admin can do. Additionally, I'm concerned that this is a scenario where the Microsoft Cloud customer who has Office 365 and Azure can't detect it, can't remediate it, and ultimately can't prevent it. So there's no real gate to lock if an Azure Active Directory global admin account is exposed. This connectivity between Azure Active Directory and Office 365, specifically Office 365, because that's what customers see it as, that a global admin can jump over to Azure, is completely unexpected and unanticipated. So when I say can't detect, there's no way in Azure Active Directory to scan accounts to detect that this configuration is set, even though it's set in Azure AD. Can't remediate it because even if you knew that an account had this set, you can't go into that account to change it. The only thing you could do is take ownership or control of that account, put it into global admins, and then toggle that back to no. That would be the only real way to remediate. I mean, technically, you could go over the Azure side and remove it from the user access administrator RBAC role at the root level, but that toggle would still be set technically on that account, even though it doesn't show up in the account properties. So the only real good answer to this is managing global administrators group with Azure Active Directory PIM, Privileged Identity Management, though even this doesn't stop a rogue admin. So using PIM reduces this risk tremendously because then whoever has an account that could elevate to global admin has to go through MFA, has to go through a control gate, like maybe an approval process. It's logged and identified that they're doing this. But outside of that, you really have to monitor the global administrator role membership in Azure AD and the user access administrator group at the Azure root level. And regarding the sensitive systems that you may have in Azure, you have to severely restrict who has access to them. Placing them in a separate subscription will prevent and protect against common over-permissioning, because you could have a subscription that's maybe your most sensitive things, and then control that subscription to just those, but not against this sort of attack. So if Office 365 is not tightened and secured, and the global admins group are not really well protected, the domain controllers, the sensitive systems that are in Azure subscriptions that are associated with this tenant are not protected against this. So leveraging a separate tenant is the best method for isolating and securing these sensitive systems. As I said, I did report this to Microsoft back in through MSRC in September 2019, continued corresponding with them, providing additional details through the rest of the year. I walked through what the detection story is, and that's when I was very concerned about this. Again, my biggest concern with this is that on the Azure AD side, there's no good way to detect, remediate, or prevent a global admin from flipping the switch and gaining full Azure rights. PIM is a gatekeeper, but there, again, in a rogue admin scenario, that would not protect against this from happening. How can we best secure Office 365? First of all, you want to limit your global admins. The scenario with Acme having 50 global admins and the Exchange admins, SharePoint admins, all these others that are thrown in there should not happen. Anyone that just needs to look at Office 365 configuration, like report accounts, should use Global Reader. Because the global admins are kind of like enterprise admins in AD plus more. Global Reader doesn't cover everything from a read-only perspective, but it's expanding. So highly recommend that you use the global reader role for anyone that just needs to see it, but then work on individual service role administration. And make sure MFA is configured for all the role admins. Start with global admins first, preferably with the Microsoft Authenticator app and no SMS or text options. This is a good way to protect the accounts and make sure that the administrators that are associated with these services and within Office 365 are well protected. But ultimately, the best way to do this is using Azure AD Privileged Identity Management. It does require Azure AD Premium 2 subscription, but only for the accounts using PIM. You do not need to get Azure AD Premium 2 for everyone in your organization. So if No matter how many users you have, if you only need 10 people that are managing your Azure Active Directory Office 365 environment, you only need those 10 to have Azure AD P2. And with PIM, you want to control your role groups with PIM. Start with global admin, and these roles that you see here, these are the ones that Trimarc has identified that can control Office 365 admin accounts, groups, and systems. It's not comprehensive because these things do change. As part of our Microsoft Cloud Security Assessment, we keep this updated. We make sure that our recommendations align with the current configuration that Microsoft has. Then you move on to controlling service admin roles. These are the ones that control Office 365 services and can access data. Again, not comprehensive, but these are the big ones: Exchange, SharePoint, Teams, Skype, Intune. And so how would you identify your role group membership within an Azure Active Directory? Well, you're going to use the Azure AD PowerShell module. You connect to it, authenticate, and then you're able to go through and enumerate the role membership. And this is a sample script you can use in order to do that. Again, our Microsoft Cloud Security Assessment goes through, identifies the role group membership, looks at subscriptions, will identify what sort of protections are configured, provide recommendations around PIM, around MFA, even if you're not using Azure Active Directory MFA, as well as the ways to best protect your administration and control of Office 365, in addition to all the settings that you can do within those. But ultimately, securing the global admin authentication is critical, as I've mentioned in this presentation. Make sure that you're using dedicated admin accounts for administration. We strongly recommend at Trimarc that you use an Azure AD account, not a synced account from your on-prem AD, but an Azure AD cloud account for administration. That way, you can use the MFA that's available for you, such as Microsoft Authenticator. You can use PIM very easily in order to enforce and protect those roles. And make sure you're using cloud admin workstations. That cannot be underscored, because once an attacker gains access to that session token, they own that environment. And then there's FIDO2 authentication. Very similar to how a smart card works. You have a PIN, you have a device, or a USB device usually, you plug it in, you have a PIN associated with it to authenticate and to access the credentialing material on that USB drive, such as a YubiKey. You have to type in your PIN. I believe there's biometric authentication devices that are out now or coming out for FIDO2, and that is your way that you authenticate. Microsoft calls this passwordless. It is a great way to authenticate because it's a stronger method and it protects against the person in the middle style attacks with your typical MFA, where if someone can person in the middle and have a server and have control a system that looks like it's the portal and get the admins to connect to that, then they can person in the middle and show the MFA request and things like that and grab the session token through that. Microsoft also strongly recommends that you create 2 emergency break glass global admin accounts. One should be excluded from MFA, one should be excluded from conditional access. That's why there's 2. The original advice was 1. This ensures that even if one of these 2 breaks, that you will still at least have the ability to use a global admin account to manage the environment. Trimarc recommends that both have a FIDO2 key configured for authentication that you put in a safe. That way you have a break glass or your break glass effectively. But you must audit logon activity for these accounts. Effectively, every alarm bell should go off if any of these accounts successfully authenticate to Azure Active Directory. This can be done through the document that is listed in the reference section that Microsoft has published, where you're looking for any kind of logon. Any kind of authentication should be well known, understood, transparent, and there should be a clear process on how to use these accounts. As I mentioned, protect Azure Active Directory Connect server and ADFS as well, like a domain controller. The Azure AD Connect service account is highly privileged in Azure AD and Active Directory, so make sure that is very well protected, much like a DC, as Microsoft calls it, a tier 0 system. And you want to ensure that Azure Active Directory Connect is running the current version. There were 6 versions released last year. We tracked this as part of our Microsoft Cloud Security Assessment at Trimarc, and we note that versions older than 18 months will be deprecated by Microsoft. You can run this command in order to identify against your cloud environment, your Microsoft cloud environment, what the Azure AD Connect version is. You can also check on your Azure AD Connect server. And then ultimately, you need to review your application permissions and consent. Microsoft has a portal area where you can go in and look at the permissions. that need to be consented to or consented to at the tenant-wide configuration, or even on a per user to see who is actually consented to applications within your environment. You can remove this capability from them so they cannot consent to it. And Microsoft is moving towards a system where you are able to do much more granular control of this and better, more streamlined permission consent workflow. But as of now, you can turn it off where users cannot consent to applications and they have to request consent, which goes to either the global admins or another group. Microsoft has published a GitHub this permissions PowerShell script, which will pull both the delegated permissions and the application permissions, and you can look at this sort of data. This is very similar to what we do when we're looking at the Office 365 environment as part of the Trimarc Microsoft Cloud Security Assessment. Enable security defaults. So if you're not currently leveraging conditional access policies right now, even if you're planning to in the near future, in the next few months, enable security defaults. Because this will protect you from a number of things, and it will disable legacy authentication. This is enabled by default on any new tenant, so you already have this. And as you're figuring out what your conditional access policies are and should be, make sure they cover these things that security defaults cover. Legacy authentication is blocked. MFA is enforced for highly privileged roles. After users complete the MFA registration, they'll be prompted for MFA if Azure AD needs to confirm their authentication because there's something weird about it. One of my favorites here is access to the Azure portal, Azure PowerShell, or Azure CLI requires MFA. Anyone not already registered has to register. This is why it's really important to make sure users at least register for MFA. They're at least configured with it, so that way you can use it. Azure AD can prompt them if they see something weird about the authentication. And this MFA within security defaults is always the Microsoft Authenticator. You'll need Azure AD P1 with conditional access to get conditional access in order to do other MFA types. But don't use security defaults with conditional access. There is a conflict there. But if you can, use conditional access. The three policies we usually recommend is to limit, disable legacy authentication, enforce MFA for role members, and restrict access to Office 365 services and SaaS apps. One thing that we do recommend that you restrict is Microsoft Flow, and now it's part of the Power X, forget exactly what it's called, but the Power components within Office 365. I'm going to cover that in a later webcast. But basically, Flow is kind of like an if this, then that. And attackers are leveraging this because once they are able to compromise an account, they can set up persistence. They can set up an if this, then that, where whenever someone gets, that they've compromised gets an email with an attachment, dump an attachment into OneDrive or send it over to this Dropbox. So Flow can be of concern, especially if it's not being actively leveraged in the environment. Conditional access can lock that sort of thing down somewhat. You definitely want to monitor Azure Active Directory and Office 365 logs, pulling them into your existing SIEM, or leverage Azure Sentinel. It's been out for over a year now. It has an associated GitHub repository with a lot of alerts and dashboards and configurations that can be copied in and leveraged to build out your detections within Azure Sentinel. Getting the Microsoft Office 365 and Azure Active Directory logs in there is at no cost to low cost. Definitely get them in there and start looking at them if you have nothing else. If you do have something else, you might even port them into Sentinel and then pull them from there in your existing SIEM. And then there's the Microsoft Secure Score. These are the quick wins that you can work through. Secure Score looks like this. It's broken out by category, and there's points assigned to it. Definitely export the Microsoft Secure Score data to Excel, or just sort it by user impact, low to moderate, and work through those that are low. When we do our Microsoft Cloud Security Assessment, we look a little bit at Microsoft Secure Score, but we've got our own list of things that we're focused on. Microsoft continues to build out Secure Score and update the scoring, so that way you have a good identification of what should be worked on first. And then the other thing you really want to work on is looking for common persistence methods. We call this common persistence methods checks. So illicit consent grants for applications, exchange forms or rules that could be potentially malicious to enable an attacker to persist in the environment. Exchange permissions, which we look at as part of our Microsoft Cloud Security Assessment, is a very popular way to persist. Basically, they compromise an Exchange admin account. They set permissions on a bunch of interesting Exchange mailboxes so they can persist as anybody. So all they need is to compromise a regular user in the environment, and they can still pull email for that mailbox. I put together this Office 365 security checklist, which covers pretty much everything that I've talked about, and maybe a couple other items. The slides will be available as well as the recording on this site here at the bottom. But ultimately, cloud is a new paradigm that requires a special attention and resource. It's not inherently secure, but the security responsibilities are shared between the provider and the customer. There's a lot of different security components and options, especially as the cloud changes. It constantly changes. I don't know what I got into by tracking the Microsoft Cloud changes, but it seems like every couple months there's some major changes to things. Thankfully, I meet with Microsoft on a regular basis to get some NDA information about what's coming down the pipe, so I can stay abreast of all these things. But ultimately, you want to make sure that you have the right settings configured for your risk profile and what you want to have and how you want to best protect yourself. So I have a number of references here, which you can see on the slides after we post them. Go ahead and register for the upcoming Trimarc webcast, and I will do Q&A now. So I'm going to switch over to the Q&A and take a look at what we have here. So let's see. And I just also want to say while I'm reviewing this, thank you very much for joining. We really appreciate everyone who joined. It's great to see this much attention paid to Office 365 and the cloud environment. So we are going through here. Let's see. Any tools to scan for Azure privilege escalation path like Bloodhound? So good question. There is a tool that was released by Dirk-Jan Mollema. I believe it's ROAD scan. I will tweet that out from my Twitter account shortly, so that way you can see what that actually is. He has an entire presentation around that tools, but it gets the information, and I believe it provides some sort of pathing around Bloodhound. I know the Bloodhound folks are looking at what can be done within the Bloodhound itself to import the pathing. I know that there's a few people that have been working on this, but I'll have to check that and then I'll tweet it out. So thank you for that question. So let's see, question or note here. Sean, I love your site, adsecurity.org. There are a lot of AD security enthusiasts out there. You should create AD Azure online training courses. Thank you, Eric. Definitely hear you on that. Jared Haight and I, who did a DerbyCon training on Windows security, attack, and defense for the past 3 years, I've actually been working to blend that Windows security training with Active Directory security training, and we are also incorporating some Azure Active Directory training as well. So we were planning on launching that this year, but with everything that went on, we were unable to do that because it's in person only. Next year, we're going to look to expand that and see what we can do. So please stay tuned. We'll see what we can do on that. Let's see. I've heard Azure Active Directory Connect will be unable to synchronize on-prem AD to Azure AD if FIPS is enabled on the server. Any truth to that? I don't know. I do know that FIPS can cause a lot of issues, and to the point where Microsoft has even recommended don't enable FIPS settings. I know that there are some governments that still require them based on usually older guidance, but I will check to see if I can get an answer for that, and if I can, I will tweet it out later. Let's see. We have vendors telling us that they need service accounts in Azure AD with global admin rights. Any recommendations for securing these accounts since MFA is not an option? This is a great question. So it's interesting that everything old is new again in the areas of Active Directory and Azure Active Directory. It's interesting how as I see Microsoft improve Azure Active Directory, I'm like, that looks really familiar. I remember that from Active Directory. And now we have vendors saying that they need service accounts with not domain admins, but global admin, because it makes everything easier. Now, granted, today, the permissioning and role definitions are not as granular as I'd like to see. Microsoft has been working on changing this. I'm not sure exactly what I'm allowed to say under NDA, so I'll just leave it at that. But we will get to a point in the future where we can customize roles in order to better control that. And that's one of the things that once that is fully available and you have the ability to import, say, a custom role, Trimarc is going to have some of those available as part of our service offerings and maybe even make some available for free. So that's down the road. I'm not sure exactly when that'll happen. Let's see, not sure how much bypassing you do, but how do you usually twist your tools in order to bypass Defender and AMSI nowadays? I heard I need to switch into C# and loading PowerShell through that, but do you have any modifications you usually use in these cases? Great question, Anonymous. We do not actually do any red teaming or pen testing. We do our security assessments. So effectively, we do all of the reconnaissance in the environment, like an attacker or a pen tester or a red teamer. And as part of that reconnaissance, we have our own custom tool that we have written that we use that covers all that reconnaissance for the three assessment areas that we cover: on-prem Active Directory, Azure Active Directory, Office 365, and VMware. These tools, we let our customers know we're going to be using them. We identify a computer we can use, and then we will run that on that computer. They do not trigger any kind of Defender or AMSI because we're not using any quote-unquote hacking tools. Again, we wrote them ourselves. They're custom and proprietary, so there's nothing around that where we need to bypass it. As far as bypassing these tools, you definitely want to follow a bunch of people on Twitter that I can't name off the top of my head, but there are a bunch of people that typically provide a lot of information around the bypasses. You can look at Dave Kennedy's Unicorn tool. I know Jared Haight did PS Attack, which effectively loaded PowerShell tools in a C# and encrypted them. So there's a lot of work that's been done around that. Not my wheelhouse though, so I will defer to the experts on that. Let's see, does Microsoft still limit MFA with PIM to Microsoft Authenticator, or could I use a third party like Duo or Improvata? That's a great question. I know that as these features first get released or initially get released, it is all based around the Microsoft MFA and the Microsoft components, because obviously that's easier to integrate and set up. My understanding is expanding PIM, expanding the self-service password reset, the registration stuff around that, as well as some of the other components that can leverage MFA. It's definitely being looked at. I don't know what the roadmap is or what's going to happen with that in the near future. The 2 emergency break glass global admin accounts is not included in the 2 to 4 recommendation, correct? Good question. I would say no. You definitely want those 2. Ideally, in the best scenario, in the best configuration, you'd have your 2 emergency break glass global admin accounts, which are permanently in global admins, and then no other account is permanently in there. All the other accounts can only go in through PIM, and PIM controls the global admin group membership or role membership. I'd say that's the best scenario. And it looks like Dean has posted for Anonymous. This script will document almost anything on Microsoft 365 dsc.com/pages/getting started. So do you do assessments in Europe? Yes, we've done many assessments in Europe. Now, of course, we're doing everything remotely, but we've done remote assessments in Europe, and we've done on-site travel assessments in Europe. We love traveling to Europe. We're not sure when that's going to happen again, but yes, we absolutely do remote assessments. We've been through the entire GDPR process, and we make sure that we follow very stringent controls of client data and protection around encryption. Let's see, what are some things that Bloodhound can do that Azure ATP properly configured with on-prem AD agents can't do? Thank you for the question, Jim. Slightly off topic, but I will accept it because it says Azure. So Microsoft has never met a word or marketing phrase they didn't love, like ATP and Azure. So Azure Advanced Threat Protection is effectively or the ATA product that Microsoft had for years in the on-prem environment. The only real difference is that Azure ATP, the sensor agent that's installed on the domain controllers to monitor for authentication and such, doesn't go to a server that you configured in your on-prem environment. It goes to the Azure ATP server cloud. So that Azure AD server cloud then parses through it and identifies what potentially is concerning as far as authentication goes. They also do some checks and have some pathing similar to what Bloodhound does. Bloodhound's been out for almost 4 years now, so there's a lot of tools that have incorporated some of the capabilities that Bloodhound is able to do. Azure ATP has some things that can do that. Bloodhound is very much about the an amazing tool written by Will Schroeder, Rohan, and Andy Robbins from SpectreOps, and so Rohan Vaskar. So amazing tool. They continue to update it. It's very active update. They're very active with the community. Great guys. Great work with Bloodhound. Bloodhound AD GitHub is the best way to search and find that. I'm sure someone will throw a link up in the Q&A chat here. But ultimately, Bloodhound is, I am on this system, or I have these systems or these credentials. How could I jump to domain admins, or how could I move in that direction? So looking at Azure ATP, it's more of the, what are the sort of attacks that we see, and what are sort of the limitations that we see in the environment that we can recommend that you can fix. So there's some crossover, but not much. We're often asked, how is what we do different than Bloodhound? We really focus on root cause analysis and not so much looking at the result of that through graph theory and pathing. We're looking at the data. We're connecting dots and figuring out what all the attack paths are in the environment based on the configuration that we see, which is similar to Bloodhound, but we represent it differently. We represent it as, these are the things you need to do, these are the things you need to fix, not so much from the pathing perspective. All right, let's see. I see a couple others that I'm going through and looking. Can you recommend a summarization of Azure Office 365 logs to monitor versus common threats just presented? Great question. That will be in a future webcast. I don't have anything to provide right now, but we will do a future webcast which talks about some additional attacks, a little more nuanced attacks, permissioning, service principles, some of the more interesting under the covers or weeds of Azure Active Directory and Office 365, which will include the event logging and defenses around that. Do you have any great PowerShell cheat sheets that you run on security assessments to check for misconfigurations in Azure AD or on-prem? AD, great question. So the webcast on June 17th, we will be talking about on-prem Active Directory. And depending on the popularity of that, if that's really popular, we will do one for performing your own Azure Active Directory and Office 365 security review as well. See, as it pertains to Microsoft Teams, what is the recommended best approach as it pertains to allowing external access and guests? We have business that wants us to open things up to allow collaboration, but are hesitant in allowing data exfil, etc. Thoughts? That is a great question. It's a tough question to answer because it does depend. Unfortunately, I hate answering perhaps, or it depends, but it really depends on the business requirements and the risks around that. You can protect your data really well if you're using Azure Information Protection or some other DRM or rights management system. That will ensure that even if someone put the document on the internet somewhere on a website, no one could actually access it. One of the recommendations that we typically make is controlling the creation of teams to an extent, and making sure that any teams that will allow external users are marked as external. Unfortunately, there's not a ton of great technical controls around that, but they are developing. Unfortunately, that's my best answer today, but maybe we can incorporate that topic as far as external users and guests in Office 365 for a future webcast. Let's see. How can an attacker identify global admin Azure AD accounts using a non-administrative regular Azure AD account? Thanks for the webcast, great info. There are some ways. I'm going to not answer that right now because I want to make sure that what I'm saying is accurate. But typically, you can get information about the role group membership without really any special privileges, much like Active Directory. There might be some exceptions to that, which I'd have to go and double check. But the ability to do that is not constrained by security controls baked into Azure AD that are different than Active Directory, to my knowledge. And is there a simple tool like Pincastle that can spot low-hanging fruit for you to fix for Azure Active Directory Office 365? Not that I'm aware of right now. I'm sure that there are some out there that I'm not aware of. We launched our Microsoft Cloud Security Assessment last year. So I'll definitely, as we're looking to doing potentially performing your own Microsoft Office 365 security review, we can make sure that we have some of that in there and provide that as well. Can you subscribe to an audit checklist for protecting your Azure environment? Definitely look at CIS, Center for Internet Security. They have a number of checklists and recommendations around Office 365 and Azure AD. Not sure about Azure itself. Can you point us at resources for looking at Office 365, not from a defend protect perspective, but from a detect, respond, and recover one, more from a SecOps point of view? I don't have any off the top of my head, but I think we should be able to put something like that together in a future webcast. And I think I'm going to find one more question and then we'll probably wrap up. All right, so what's your recommendation for customers who still have ADFS but only use that for Office 365 logon? Is it still best to completely migrate to password hash sync, or does ADFS still have benefit I'm not aware of? My opinion is that ADFS is not going to be around in the future, maybe 5 to 10 years from now. That's my personal guess. Sean guessing that. I don't have any special information around that. But Microsoft has provided pass-through authentication. There's password hash sync. And off the top of my head, there's a third one that I can't think of right at the moment. And there's some a roadmap and migration methods to get from ADFS to move into those directions. Federation is useful if you have if you're just federating for Office 365. Yeah, those are the best ways to move to. I can't think of a good reason to stay on ADFS for that. If you have a whole bunch of cloud SaaS apps that you're leveraging through federation, then yeah, it probably would make sense to maybe stay with ADFS or something like that. And I am not saying at all that Trimarc is saying that you need to get rid of ADFS or that Microsoft has stated that it's going away. That is not being said. This is Sean's opinion that at some point ADFS is not going to be around in the future. So that is part of why Microsoft is providing these migrations away from it. Now, from an ADFS perspective, you absolutely 100% need to be on ADFS running on Windows Server 2016 and make sure Smart Lockout and a number of other security features are enabled. I think we'll cover some of that in a future webcast around our Securing Office 365 and Azure AD web series. So I'm going to wrap up now. If there's any other questions that I did not get answered, I will try to get those and see if I can handle those on Twitter. Thank you very, very much for joining us. I really appreciate you all being here. As we mentioned earlier, the slides and the video recording of this will be provided on the Trimarc website at the link at the bottom there, trimarc.co/security-webcasts. And I'm excited to announce that we will be launching the Trimarc Content Hub, which will be announced and released officially in the next couple of days, which will contain all of our webcasts, our slides, as well as all the presentation videos and slides that are available from past presentations I've done, as well as new articles, blog posts, and things along those lines that Trimarc has developed or I've developed. So we'll have that launching in the very near future, as in this week. So thank you very much again. Visit trimarcsecurity.com for more information about our Active Directory, Office 365, and VMware security assessments. And take care of yourself. Have a great day. Really appreciate you being with us. Take care.